Hello everyone, welcome to Unit 4 of our 6th grade science class. Today we're going to be looking at notes on the layers of the Earth. There's 4 main layers to the Earth. The crust is the outermost layer. The mantle is beneath the crust. The outer core is beneath the mantle. And the inner core is the deepest layer of all. And it's important to remember that at one point the entire Earth was molten as a liquid, and then it separated by the densities of those liquids. That means the outer core is the most dense. That material sank all the way to the middle. The inner core is the most dense. The outer core is the next most dense. Then the mantle, and the least dense layer is the crust. So those layers are all sorted by their density. As we explore those layers, we're going to start with the outside and work our way in. And that means we're starting with the crust. The crust is the outermost layer of the Earth. And there's 2 main types of crust. There's continental crust, which is made mostly of a rock called granite. And there's oceanic crust, which is made mostly of a rock called basalt. Granite is less dense than basalt, so continental crust is less dense than the oceanic crust. Oceanic crust is also very thin at only 10 kilometers thick. Continental crust is quite a bit thicker at 30 to 50 kilometers thick. Moving down from the crust, we'll reach the mantle. The mantle lies directly beneath the crust. It is the thickest layer of the Earth, and it is about 2,900 kilometers thick. And then the mantle is divided into 3 separate layers. The mantle also gets hotter the further down or the deeper that you go. It's about 1,000 degrees Fahrenheit right near the crust, which would be up here. It's about 1,000 degrees Fahrenheit. Down here near the outer core, it's about 7,000 degrees Fahrenheit. So it gets a lot hotter the further down that we go. We're going to take a closer look at those 3 different layers of the mantle, but let's summarize the 3 layers first. The lithosphere is the uppermost part of the mantle, but the lithosphere also contains the crust. So the lithosphere doesn't just contain mantle, it also contains the crust. So it's the outermost layer of the Earth plus a little bit of mantle. The asthenosphere is located directly below the lithosphere. And the asthenosphere contains convection currents. And these convection currents are what allow the tectonic plates to move, so they drive the movement of the tectonic plates. Beneath the asthenosphere is the mesosphere. And the mesosphere is the deepest layer of the mantle. It's the furthest down, and it is also the thickest layer of the mantle. Let's take a look at those layers in more detail, starting with the lithosphere. The lithosphere is divided into several large chunks called tectonic plates. And the lithosphere is also rigid and brittle. Rigid means it's not going to squish or compress, and brittle means that it's going to break. So if we add large forces to the lithosphere, it's going to just break into smaller chunks. Beneath the lithosphere is the asthenosphere. And the asthenosphere behaves very differently because it's hotter. So the asthenosphere is located beneath the lithosphere. And the asthenosphere is what we would call plastic. And this doesn't mean that it's made of plastic. It means that it's able to bend and flow. So if you apply a force to the lithosphere, it just kind of bends. It doesn't break. And this ability, even though it's solid, so this ability to flow drives that tectonic plate movement. The tectonic plates float on top of the lithosphere, and this ability to flow makes the tectonic plates move. And that's happening through those convection currents that we learned about in the unit on heat. So just as a reminder, let me switch colors here. In a convection current, we have to have some sort of heat source. We have a heat source at the bottom, and that heat makes the material less dense, so it rises up until it reaches some sort of barrier, and then those spread out, at which point they cool down, get more dense and sink, and then flow back towards that heat source. Now, I've drawn this convection current in the wrong layer because there's much more room. Realistically, the asthenosphere is very, very small, and I wouldn't be able to draw that convection current with much detail. But as you can imagine, on these areas where the convection current is spreading apart, that would cause the tectonic plates to move in the same direction. Moving down to the mesosphere. So we said earlier the mesosphere is the deepest. So let me switch back to white. The mesosphere is the deepest layer of the mantle. It is also the thickest layer of the mantle, so it's the largest in size, and it is the hottest layer of the mantle. And it is the heat from this layer, from the mesosphere, that causes the convection currents to form in the asthenosphere. It causes those convection currents to form. That's the last layer of the mantle, so let's take a look at the outer core next. The outer core is very unique because it's the only core that is a liquid. And it's also not made of rocky material like we would normally think of. It is made of iron and nickel, and it's almost entirely iron. There's just a very little bit of nickel. The outer core is also very thick. It's about 2,200 kilometers thick, so not that much smaller than the mantle. And this layer is so hot that it is a liquid. This layer is a liquid. And what's so important about that is if you have liquid flowing iron, it creates a magnetic field. So this liquid creates a magnetic field around the Earth. And not only does that a magnetic field allow compasses to point towards the north, but this magnetic field also protects Earth from the solar radiation, that solar wind. So it protects the Earth, and it's one of the main reasons we can have life on this planet. The liquid core there is very, very important. And then beneath the outer core, we have the inner core. And in a lot of ways, this is very similar to the outer core. The inner core is also made almost entirely of iron with a little bit of nickel. This is smaller. It's only about 1,400 kilometers thick. So it's not as thick as the outer core. And then even though it's hotter than the outer core, it is under so much pressure. The inner core has so much pressure from the weight of the Earth above it that it is still a solid. It is not a liquid. This layer is solid because it's under so much pressure that those atoms are locked in place. If you remember back to our unit on atoms and solid liquids and gases, solids, the atoms can't move around freely. They just vibrate back and forth in place. And it's the pressure of all of these cores. So the crust, the mantle, and the outer core, that pressure pushes down on the inner core and locks those atoms in place, keeping it a solid. That's going to do it for our notes on the layers of the Earth. See you next time when we talk about tectonic plate boundaries.